Okay, so again, we're doing the second of the the three videos that we're going to do on hypothesis testing. So here we are. I'm reminding you where we started. We went through and talked about the general structure of an argument. The argument has to go a certain way. There are two sides to the argument. There's a person in the front of the room. You can see that person talking. There's a person in the seats. You can see they've raised a hand. They're going to speak also. Both of them are going to make a claim. So there are going to be colons involved. I claim colon, and the person in the seat says I claim colon. Okay? And when we went through and talked about the different arguments, we talked about two different things. One is that we talked about the null and alternative hypotheses, and we use symbols for those. And then the second thing is we talked about how do you calculate the numbers that you need for the argument. So overall, there's three things that a person needs to understand this chapter. They have to have a sense of how a hypothesis test argument goes. And at the end of the last video, I talked about how crucial it is that you not try to put numbers in places just by guessing where they go, but instead try to understand, try to focus on the sense of the argument. Second, you have to state the hypotheses with symbols, and you have to be able to read them when somebody else states them with symbols. That's what we're going to work on today in this video. And third, you have to be able to make the argument yourself, including doing the calculations, and not surprisingly, that's what the third of the three videos is. Okay, so let's scoot forward here past the definitions and over to stating the hypotheses. I've mentioned here, so these are word problems. Word problems give people trouble. I mean, I get it. There's lots of things that give me trouble, and the only way you can work on things that give you trouble is you sort of try one, look to correct it, try another one, look to correct it, that kind of stuff. So that's what we're going to do. We're going to practice with a bunch of these. Okay, so the first example, naturally you try to start off with somewhat easier examples, so more straightforward examples. First example is the current drug for high blood pressure lowers that number by an average of 25. You're testing a new drug, state the hypotheses. I want to state them in symbols. Okay, so there's two people arguing, the doctor in the front of the room, or the person in the front of the room, and the person in the seats. This is the person in the seats, the null hypothesis. This is the person in the front of the room. Naturally, the person in the front of the room showed up to report that they have a new drug that does better. And the people in the seats, they're not liar, pants on fire, but they're saying you have to provide evidence to convince us because the default case is that the new drug isn't any better. How do you say that in symbols? So here's how we say the folks in the seats. The folks in the seats, remember, they're about I claim, and there's a colon. So H naught is not a variable. H naught is a person. It's like if it said Jerry, Susan. I mean, this is a person, colon. And what that person says is what's on the other side of the equation. This is the person in the front of the room, person speaking, colon, I claim, colon. And here's what they claim. Okay, well, obviously the person in the front of the room claims that the new drug is better, so they have bigger than 25. And, of course, the person in the seats says back to them, well, you're going to have to provide evidence for that because the default case is to believe that the new drug isn't any better. So let's look at the structure of what's here. Again, H naught and HA are not variables, they are people. So they have to have these colons that say, I claim. These two numbers, 25s, they're always going to be the same. You won't ever have 25 here and 35 here. Never. They always have to be the same. What's here? So what's here is always a population number. This question, of course, is about average, so it's going to be the average for a population. So that's why it's a mu, not an x bar. Never will it be an x bar. Never will it be a p hat. Never will it be an r. It's always going to be the population number. This is a population average, so it's always going to be the population average mu. This symbol right here is always going to be equals. Always going to be equals. So there's a lot of pattern to what we're looking at. A person can say, not so much fill in the blanks, but I understand why the pattern is there. They are claiming that if you gave this drug not just to the sample, but instead to the entire world, you would see a net loss in blood pressure of greater than 25. That's why it says mu, because if you gave the drug to the entire world, we know what happened when you gave it to the sample. We did the sample. So we must be arguing about the entire world. We don't care about the sample, we care about the population. Okay, so again, very quickly, H naught and HA always have colons. They're not variables. They never equal something, never. These are always the same, and they're always the population. It could be mu, it could be p, sort of stuff. These two numbers are always the same, always the same. And that's always in equals. So there's some pattern a person can look for as a skeleton to help them fill in the parts. Let's try another one. Your quality control inspector, every morning you go out on the factory floor and you test the machines by producing a sample of widget to make sure that today's machines are still producing the right diameter, happens to be 3.4 centimeters. Okay, in words, this is the null and alternative hypotheses. The null hypothesis is always that there's nothing of interest happening. The alternative hypothesis is always that something genuine is happening. That if you get a number that's not equal to 3.4, it's because there's something going on. All right. Now that's in words. We have to do it in symbols. So here we go for symbols. H naught is that mu is equal to 3.4. There's nothing happening. Today the machines are doing what they're supposed to do. That front that came through last night with the change in air pressure had no effect. HA is that mu is not equal to 3.4. I'm not sure, is it bigger? I'm not sure, is it less? I'm concerned in either case. I mean, I need my machines to be making the right size parts. Okay, so again, the idea is that we have people in the seats who are saying, you've got to convince me something has happened. And HA is saying, I'm worried about the following things, that the following things are of interest. Up here, greater than 25 was of interest. Here, other than 3.4 is of interest. Again, I'm going to point out the skeleton, but again with the caution that you can't just look at the skeleton and say, I'm going to pay attention to nothing, I'm just going to drop numbers in places. It's very important to understand the argument. But as a help to understand the argument, H naught and HA have colons because they are people. You know, I assert, colon, I assert, colon. This is the person in the front of the room. This is the person in the seats. The kind of general community. The null hypothesis is that there's nothing of interest. So today is just like every other day. 3.4 is the nominal number. The quality control inspector is concerned about greater than 3.4, also concerned about less than 3.4. So when the quality control inspector picks up their clipboard and heads off for the shop floor, they're making the hypotheses up in advance of the experiment. So in their mind, they're saying to themselves, well, I'm concerned about both greater and less than, so I got to write unequal. Another example. Again, just going to do a number of examples, hoping that a person by the end will be saying like, I get it, I get it. Well, that's a good, I much rather have I get it than I don't get it, I don't get it. Okay, so you're an education researcher and you want to know whether people do worse on the test when they study while they're listening to music. So you have a treatment group that we're going to call group 1 and a control group that we're going to call group 2. We're going to report the percentage of each group that passes, and I want what are the hypotheses? How do I express what my concerns are in this experiment? As usual in English, I'm going to drop the English after a while, but for the moment, English is a help. The null hypothesis is that the music makes no difference. The alternative hypothesis is that the music makes it likely that you'll do worse on the test. So always the null hypothesis is that there's nothing of interest, and the alternative hypothesis always is that there is something happening here. There's a genuine phenomenon. Okay, so I've stated the exact same thing two different ways, just to have, you'll see it both ways, so I'm just showing you both ways. H naught, again, is what it is that people who think there's nothing of interest happening here think, and HA is what it is that people who think there is something of interest happening think. Group 1 is the treatment group, group 2 is the control group. So H naught thinks that if you took the average test score for the treatment group, you took the percentage of each group that passed, the percentage of people who passed in group 1 and the percentage of people who passed in group 2 and subtract, you'd find 0. And again, that's not a sample number, that's a population number, because we don't care about the sample, we care about if everybody in the world studied math while listening to music, what would happen. So H naught is asserting that music makes no difference in how you score in the math test, so you'd see a 0. HA is asserting that music does make a difference, music makes you do worse. So math people score lower than music people score lower than non-music people, so you'd see a negative number. Of course, algebraically, what's over here and what's over here are exactly the same way. I like it this way, but you very often see it this way, so I'm showing it to you both ways. So again, the null hypothesis is that if you took everybody in the world and made them listen to music while studying math, and then took everybody in the world and didn't allow them to listen to music while studying math, you wouldn't see any difference. And the alternative hypothesis is the opposite, that you would see a difference. The people who listen to music while studying math do worse. Another example, how left-handed and right-handed people do at math. So you get a sample of students to declare their handedness, you give them an exam, and you report their averages on a test. So state hypotheses. The null hypothesis is surely that handedness doesn't make any difference. The alternative hypothesis is that handedness does make a difference, right? Isn't that what you would think? So the alternative hypothesis is that there's a genuine phenomenon relating handedness to score on the test, and the null hypothesis is that no, there isn't. And if you find some difference in your sample, it's just because of routine sample variation. It's not because it's a genuine phenomenon, it's just because samples vary, that's all. That's what the null people think. All right, so how do we state those 2 points of view in terms of a formula? And again, formulas give some people trouble. So we're going through a number of them. Formulas very sensibly give some people trouble. So you see on this slide again, always H naught and HA have a colon. Never does it say H naught equals or something like that. Never. You always have the population symbols here. So this doesn't say x bar 1 and x bar 2. It says mu 1 and mu 2 because we don't care about the population. Excuse me, we don't care about the sample, we care about the population. If we took every left-handed person in the world and every right-handed person in the world, what would we find? And the null hypothesis people are saying you wouldn't find any difference. So to here, if we took every left-handed person in the world and every right-handed person in the world, what do the HA people say? Well, when you read the question, it doesn't tell you better or worse. It just says different. So this just says different. It doesn't say greater than 0. It doesn't say less than 0. It just says different than 0. And again, this is algebraic, exactly the same thing. You'll see it one way, you'll see it the other way. I like it this way, but you sometimes see it the other way. Okay, so we've done a number of these now, and we're going to do a couple more. We've done a number of these now, and again, there's a pattern to them. They all have, that doesn't mean that you can do it without thinking, but it does mean that you can say to yourself, I need to slot this here, I need to slot this here. The reason I need to slot it here is because of this. The reason I need to slot it here is because it should start to make sense at some point, and that's a good feeling. I love it when I'm looking at some technical material and all of a sudden I say, I get it. That's a great feeling. Okay, so here's another example. Again, I'd rather have people go, I get it already, than people say, I don't get it. So here we go. Rather have too many than too few. You want to see if people over 70 who can walk a quarter mile have a larger 5-year survival rate than people over 70 who can't walk a quarter mile. So of course, we're going to look at a sample and report what percentage of people who can walk the distance live 5 more years, and what percentage of people who can't walk the distance live 5 more years. Right, so state the hypotheses. So the null hypothesis, of course, is going to be that walking a quarter mile is not a predictor. The alternative hypothesis is that walking a quarter mile is a predictor of living 5 more years. So no more with the English. H naught is that if you look at the percentage of people who can walk the distance and live 5 more years, and the percentage of people who can't walk the distance and live 5 more years, you'll find no difference. HA is that being able to walk a quarter mile does make you more likely to live 5 more years. So if you can walk a quarter mile, the percentage of people who live 5 more years will be bigger than the percentage of people who can't walk a quarter mile and live 5 more years. And again, I like it this way, but algebraically it's exactly the same as the other way. You'll see it the other way sometimes. I like it this way. Anyway, I should show you both just to make sure you've seen them both. And again, H naught colon, HA colon, and again, these are population symbols, not sample symbols. And again, that's an equal sign. And again, these two are always the same, always the same. See, that's why I like this version better than this version, because this version has a very strong pattern, and I like the pattern. I think it helps the person learning the material. Okay, 2 more examples. We want to test to see if an orchestra is more likely to pick a new violin player as female if during the audition they don't know the gender. So these days they put up a screen. So you have a group of orchestras do a blind test, and that's group one, and a group two doesn't. There's the hypotheses. H naught is that the percentage of females picked with a blind test and the percentage of females picked without a blind test, no difference. HA is the percentage of females picked with a blind test is bigger than the percentage without a blind test. Okay, again, the same pattern. And the last example. You want to see if having an orchestra that's more than 25% females affects the chance of picking a new violin player who's female. State the hypotheses. And again, we're looking here at this case of unequal to 0 simply because it doesn't say whether it's more likely or less likely, so I wrote unequal. But the same pattern that you see in the others works here too. Okay, very good. So of course for homework we're going to practice those some more, but I hope that a person gets a sense that doing a number of these you start saying to yourself, there's a pattern to them. They make some kind of sense. Okay, very good.